The term El Niño comes from Spanish. It means the Christ child. The origin of this name is a story in itself. In the early 19th century, fishermen in Peru, South America, noticed a peculiar phenomenon. Around Christmas time in certain years, the water temperature in the eastern Pacific Ocean would rise abnormally, causing massive die-offs of fish. The fishermen couldn't explain this anomaly. So they linked this phenomenon to the birth of the Christ child from the Bible, calling it El Niño. Back then, no one could have imagined that this seemingly local fishing issue would, decades later, become a major scientific puzzle plaguing the global climate system. Even less could anyone have imagined that a name coined by fishermen would, today, become a word frequently heard on the nightly news, and an invisible hand determining crop yields, urban safety, and even the trajectory of the world economy. To understand El Niño, one must first understand the most fundamental climate mechanism of this blue planet beneath our feet. The Earth's atmosphere and oceans are not two separate systems. They are more like a pair of perfectly synchronized dance partners, constantly exchanging energy and matter. The ocean stores the majority of the solar radiation's heat, while the atmosphere is responsible for redistributing that heat across the globe. When the two dance in harmony, Earth's climate maintains a relatively stable rhythm. But when their steps fall out of sync, El Niño may quietly take the stage. In a normal year, constant trade winds blow across the Pacific. These winds act like a massive pump, set in place by the Earth, pushing the warm surface water of the western Pacific in a steady, unending flow toward Australia and Indonesia. In the western Pacific Ocean, a massive volume of warm water gathers. The sea level is actually dozens of centimeters higher than in the eastern Pacific. At the same time, in the equatorial eastern Pacific region, in order to replenish the surface warm water that has been blown away, cold water from the depths of the ocean constantly wells up, bringing with it a wealth of nutrients. This also maintains the equatorial eastern Pacific in a relatively cool state. This pattern of sea temperature distribution is the foundation for the normal operation of the Earth's climate system. It is precisely this normal state that created the world-famous fishing grounds off the coast of Peru. When the nutrient-rich cold water from the deep sea surges upward, plankton multiply in huge numbers. Fish that feed on this plankton then thrive, and millions of tons of catch are shipped from here to global markets, nourishing dinner tables thousands of miles away. This stretch of ocean generates billions of dollars in fishery value every year, and is a pillar of the Peruvian economy. However, once El Niño arrives, this well-oiled oceanic machine suddenly short-circuits. The consequences extend far beyond just the fishing grounds. When El Niño occurs, the trade winds, which act like a giant pump, suddenly weaken, or even blow in the opposite direction for a time. Losing the push from the trade winds, the warm water that had piled up in the western Pacific begins to flow back eastward, as if pushed by an invisible hand across the equator, surging toward the coast of South America. Meanwhile, the upwelling motion of deep, cold water in the equatorial eastern Pacific also weakens significantly, even stops completely. The warm water is no longer carried away, but instead accumulates directly on the surface, causing an abnormal rise in sea temperatures in the equatorial eastern Pacific. The numbers behind this rise in sea temperature might seem insignificant, but global meteorologists define an El Niño event by it means that in the central and eastern tropical Pacific, sea temperatures are at least 0.5 degrees Celsius higher than the historical average for that time of year. See, that tiny figure of 0.5 degrees. In our daily lives, it's practically negligible. If a cup of coffee cools down by 0.5 degrees, you wouldn't even taste the difference. If the room temperature fluctuates by 0.5 degrees overnight, you wouldn't even notice. But in the ocean, that massive reservoir of heat, an anomaly of 0.5 degrees holds a staggering amount of energy. According to scientific estimates, this 0.5 degree rise is equivalent to the energy released by the simultaneous detonation of thousands of atomic bombs into the atmosphere. This energy doesn't just disappear into thin air. It heats up the air, drives convection, and shifts the patterns of atmospheric circulation, eventually manifesting as various extreme weather events that ripple out to every corner of the planet. This is the most fascinating aspect of El Niño. A tiny shift in temperature in one localized part of the ocean can, through the coupling of the atmosphere and the sea, trigger a chain reaction that alters the climate of the entire planet. That is no exaggeration. It is a scientific fact confirmed by decades of meteorological observation and theoretical research. Once you understand this principle, you understand the underlying logic behind all the phenomena we are going to explore today. How exactly can sea temperature changes in the equatorial Pacific affect weather thousands of miles away? To explain the transmission mechanism, we have to start with atmospheric circulation. In a normal year, there exists a famous atmospheric circulation system in the equatorial Pacific region, the Walker circulation. This circulation is named after Sir Gilbert Walker, the British meteorologist, who, back in the early 20th century, discovered this climate regulator that spans the Pacific. The way the Walker circulation works is like this. In the western Pacific, warm, rising air carries a massive amount of water vapor, forming convective cloud clusters. As this air cools at high altitudes, it spreads out to both sides. Part of the air over the eastern Pacific sinks, completing a full circulation loop. This circulation acts like a massive thermal engine set by the Earth, redistributing the energy of the tropical Pacific into the global atmospheric system. When El Niño arrives, the Walker circulation engine suddenly malfunctions. Due to an abnormal rise in sea surface temperatures in the eastern equatorial Pacific, the convection center that should have formed over the western Pacific begins to shift eastward. This means the water vapor that originally gathered in the western Pacific starts moving toward the eastern Pacific. The dry air that normally sinks over the eastern Pacific is replaced by warm, rising currents. The entire pattern of the Walker circulation is completely disrupted, and the energy balance of the Earth's atmospheric system undergoes a drastic adjustment as a result. The collapse of the Walker circulation is just the beginning. More importantly, this shift in energy balance spreads outward through the atmospheric circulation network, eventually affecting the weather in every corner of the globe. Scientists use the term teleconnection to describe these long-distance climate links. The sea surface temperature anomalies triggered by El Niño heat up the air near the equator, forming unusually intense rising convection. This rising air carries a vast amount of heat into the upper atmosphere, then spreads toward the poles, influencing the state of atmospheric circulation in mid-latitude regions. A prime example is the deflection of the jet stream. The jet stream is a high-speed air current located high above 30 to 60 degrees north latitude. This belt is a key factor determining the weather systems in densely populated areas like North America, Europe, and East Asia. During an El Niño, the abnormal heating of the equatorial Pacific, it will alter the temperature gradient distribution of the atmosphere, causing the position and intensity of the jet stream to shift. Sometimes, the jet stream is forced to veer northward, resulting in an unusually warm winter. Other times, the jet stream becomes much more volatile, frequently triggering cold waves to surge southward. In Europe and North America, scientists have already observed a clear statistical correlation between El Niño and warm winters. as well as cold waves and blizzards. The Indian Ocean monsoon system is also deeply affected by El Niño. In regions like India, Southeast Asia, and East Africa, agricultural production and daily water usage for hundreds of millions of people rely heavily on the annual summer monsoon rains. And El Niño directly disrupts the operation of the monsoon system. Statistical data shows that about 60% of strong El Niño years experience a weak Indian monsoon with below-average rainfall. This isn't because El Niño directly steals the water vapor from the monsoon, but rather because El Niño alters the large-scale atmospheric circulation pattern, interfering with the formation and development of monsoon low-pressure systems. When El Niño comes knocking, Indian farmers may have to face a difficult year, with a delayed rainy season and reduced rainfall. If you feel that these geographical distances are far enough away, then let us turn our gaze to even further places. From 2015 to 2016, occurred one of the strongest El Niño events on record. In that year, the East African region experienced severe drought, leading to a drastic reduction in food production, with millions facing the threat of famine. At the same time, northeastern Brazil, on the other side of the planet, also plunged into a historic, rare drought. Many reservoirs hit rock bottom, and urban water supplies were in crisis. Behind these seemingly unrelated regional disasters, all bear the shadow of El Niño. Atmospheric circulation takes the signals of sea surface temperature changes in the equatorial Pacific and transmits them to every corner of the Earth, weaving an invisible climate network. Every node in this network, whether it's farmlands in India, cities in America, or the grasslands of Africa, will experience a corresponding chain reaction. Because of a fever in the equatorial Pacific, this is the most profound revelation of El Niño. The Earth's climate system is an indivisible whole. No one can stay immune. From 1982 to 1983, an unprecedented El Niño event swept across the globe. This was the moment humanity truly witnessed the destructive power of El Niño for the first time. Before this, although fishermen had noticed this recurring, cyclical phenomenon, the scientific community's understanding of El Niño was still limited to vague descriptions. This event changed everything. That year, on the west coast of South America, the rainstorms came with extraordinary violence. Peru suffered from unprecedented flooding. Countless homes were washed away. Infrastructure was severely damaged. And on the other side of the planet, Australia was enduring a completely different disaster. An unprecedented drought swept across the eastern part of the continent. Millions of livestock died, and wildfires raged for months on end. The monsoon season on the Indian subcontinent was severely disrupted. Rainfall plummeted to historic lows. Agriculture was hit hard. Kenya and Ethiopia in the Horn of Africa were trapped in severe drought and a humanitarian crisis. The global economic losses caused by this catastrophe reached as high as $13 billion. In that era, this was an astronomical amount of loss. The most significant legacy of this catastrophe was that it made humanity realize for the first time that El Niño is not just a regional phenomenon, but rather a massive force capable of impacting the global climate system. Before this, national meteorological agencies operated in silos, and their forecasting and monitoring of El Niño lacked international coordination. Following this event, the United Nations Environment Programme and the World Meteorological Organization pushed for the establishment of an international El Niño observation network. Countries began sharing ocean buoy data, satellite observations, and meteorological forecast models. An era of global collaboration in monitoring El Niño had thus begun. 15 years later, from 1997 to 1998, Another super El Niño struck. This time, humanity's early warning systems were already partially in place. Yet the scale and reach of this disaster still exceeded everyone's expectations. In Yunnan, China, coffee-growing regions suffered a devastating blow due to the abnormal rainfall and temperature fluctuations caused by El Niño. Coffee bean yields plummeted, with some years even seeing total crop failure. For the first time, coffee farmers in Yunnan felt firsthand how shifts in sea temperatures off the coast of South America could translate directly into financial losses in their own hands. In the East Africa region in 1997, they experienced a severe spread of epidemics. Food shortages caused by drought led to a sharp increase in the malnourished population. And these individuals were precisely the easiest targets for various infectious diseases. Cholera, malaria, and other illnesses spread through refugee camps, causing a massive number of deaths that could have been avoided. In the waters off Cancun, Mexico, a coral bleaching event was underway. The abnormally rising sea temperatures caused the symbiotic algae to leave the coral tissues, losing the nutrients provided by these colorful algae. The coral gradually turns white and weakens, and eventually dies. The coral reef communities along the Mexican Caribbean coast, during those few years, lost more than half of their total coverage. The El Niño event of 1997 to 1998 gave birth to the prototype of modern El Niño early warning systems. Meteorological departments in various countries began to try issuing El Niño warnings in advance to help with agricultural water management and disaster prevention. Buying precious time for preparation, scientists realized that, although they cannot stop El Niño from happening, at least they could buy time to let society get ready to cope. Entering the 21st century, records of El Niño events have become increasingly rich, and scientists' understanding of it has deepened as well. 2015 to 2016 was the strongest El Niño event since instrument recording began. This time, scientists issued warnings months in advance. Governments around the world also began to incorporate El Niño alerts into their standardized disaster prevention and reduction systems. However, when the event actually struck, its intensity still exceeded all model predictions. Many places around the globe experienced extreme weather events simultaneously. Droughts in the Philippines, floods in Australia, heatwaves in India, rainstorms in Argentina. This domino effect on global climate was far more ferocious than anyone had anticipated. The history of El Niño is also a history of human society waking up to reality, moving from being passive victims to active responders. Every disaster pushes scientific progress forward. Every heavy loss is birthing more perfected warning mechanisms. Today we are able to relatively accurately forecast the formation and evolution of El Niño. Behind this is decades of accumulated observations, theoretical research, and technological advancement. But is this progress enough? I'm afraid the answer isn't very optimistic. The classic triple threat of an El Niño year: wetter rainy seasons, drier dry seasons, and more extreme heatwaves. This isn't just some subjective guess. It's based on decades of statistical analysis of meteorological data, an ironclad rule derived from the facts. Whenever El Niño comes knocking, the weather seems to love going to extremes. Traditionally wet regions become even wetter, while regions that are usually dry face the threat of even more severe droughts. Seasons that are typically mild turn unusually volatile. Hot summers get even hotter. Cold winters get even colder. Behind these seemingly contradictory extremes, there is actually a unified logic. To understand this logic, we need to rethink the role of water vapor in Earth's climate system. Water vapor in the atmosphere is the lifeblood of the climate system. It flows constantly, through the vast cycle of ocean evaporation, atmospheric transport, and terrestrial rainfall, flowing continuously, maintaining the global water balance. The core function of El Niño is essentially to redistribute the delivery routes of global water vapor suppliers. The water vapor that should have been transported westward may now shift eastward or in other directions. Rainfall that would typically gather in one specific area might now be displaced hundreds or even thousands of kilometers away. Take the East Asian monsoon region as an example. In a normal year, as summer arrives, warm, moist air currents from the Pacific carry massive amounts of water vapor and move toward the northwest, bringing abundant summer rainfall to regions like China, Japan, and South Korea. The punctual arrival of these monsoon rains ensures the safety of water supplies for agriculture and the daily lives of hundreds of millions of people. When El Niño arrives, this stable delivery route begins to veer off course. The sea surface temperatures in the western Pacific are relatively lower than usual. Convective activity has weakened. The transport of moisture via the monsoon winds has weakened along with it. The result is that the North China and Northeast regions may face a much more severe spring drought. Meanwhile, the South China region could experience unusual flooding. This situation where areas that should get rain don't, and areas that shouldn't get rain end up flooded, is a direct consequence of El Niño, reshaping the global distribution of moisture. Statistical data shows that, during an El Niño year, the plum rain season in the middle and lower reaches of the Yangtze River often tends to arrive early and depart quickly. The plum rain period is shortened, yet the rainfall can become even more concentrated. While this shift might seem like a minor adjustment in weather patterns, it actually has a profound impact on agricultural production. The Yangtze River Basin is China's most vital rice-producing region, and rice growth has extremely precise water requirements. A lack of water during the transplanting stage leads to the seedlings withering. A lack of water during the heading stage directly cuts into the harvest. The way El Niño disrupts the plum rain hits exactly when the rice is at its most sensitive stage. The resulting agricultural losses are often hidden. They lack the visual impact of a flood, and they don't carry the dramatic intensity of a hurricane, yet they quietly and steadily shrink the weight of our grain reserves. The impact of El Niño on precipitation is already a significant challenge, but its contribution to rising temperatures is even more concerning. During an El Niño summer, the probability of extreme heat events rises significantly. The mechanism behind this is that the unusually warm waters in the equatorial Pacific act just like a radiator that is constantly running, continuously pumping extra heat into the atmosphere. Although this direct influence fades significantly in inland areas far from the Pacific, the atmospheric circulation anomalies caused by El Niño indirectly increase the likelihood and the duration of heatwaves. In North America and Europe, numerous studies have already confirmed this. The statistical link between El Niño and extreme heatwaves. Against the backdrop of global warming, El Niño is causing extreme weather to go from a once-in-a-century event to a once-in-a-decade occurrence, or even something we see every single year. In the past, people were used to using terms like once in so many years to describe extreme weather events. A 50-year flood, a 100-year heatwave. These terms imply that these events are rare and have a low probability of occurring. However, with the ongoing, compounding effects of global warming, El Niño seems to be pushing past the Earth's safe climate boundaries. Those extreme events once labeled as once in a century might now happen every 10 years. Those climate conditions that were once thought impossible are turning from news headlines into the new normal. We are already standing on the threshold of a complete restructuring of our climate norms. This isn't just alarmism. It is a scientific judgment based on observational data. Over the past 10 years, the number of temperature records broken has risen exponentially. The frequency of news reports about extreme weather events is climbing at the same time. Behind all this, there is not only the long-term trend of global warming driving it, but also the compounding effects of annual and seasonal climate variations like El Niño at play. When the extreme becomes the normal, when the rare becomes the common, our agriculture, our cities, and the ecosystems we rely on will all face unprecedented pressure to adapt. The global food production system is highly dependent on our climate. And this point is vividly illustrated during El Niño events. Wheat, rice, and corn. These three most important staple foods in the world have a clear cause and effect relationship between their yields and price fluctuations and climate anomalies. And the other end of this chain is precisely linked to the sea surface temperature changes in the equatorial Pacific. Let's first take a look at wheat, as the most widely grown food crop across the globe. The primary production areas for wheat are concentrated in the Great Plains of the United States, the Canadian prairies, the East European plain in Russia and northern China. While these regions may seem worlds apart, they are linked by an invisible thread, atmospheric circulation, which connects them closely to El Niño. The irregular rainfall patterns triggered by El Niño directly impact the irrigation conditions and soil moisture of these wheat fields. During an El Niño year, the Great Plains of the United States may experience more frequent blizzards and extreme cold, which threatens the survival rate of winter wheat. Meanwhile, the major wheat-producing regions in Russia and Ukraine may face the threat of intensified drought. Any decrease in production from these regions will ripple through the global food trade network, affecting the international market, and, ultimately, impacting global wheat prices and the food expenditures of billions of people who rely on wheat as a staple. The fate of rice is similarly intertwined with El Niño. Asia accounts for over 90% of global rice production, and rice farming in Asia is extremely dependent on monsoon rainfall. When El Niño disrupts the monsoon system, it strikes right at the heart of rice production. Statistical data shows that, during strong El Niño years, rice yields in Southeast and South Asia drop by an average of 5 to 10%. That might sound like a small number, but in a global market where supply and demand are already tight, that 5 to 10% shortfall could mean that tens of millions of people face the risk of food insecurity. The way El Niño impacts agriculture goes far beyond direct factors like rainfall and temperature. Outbreaks of pests and diseases are another often overlooked, yet equally deadly threat. Stemming from changing climatic conditions, it will impact the breeding cycles of pests, their migration paths and the scale of outbreaks. Studies have shown that, during El Niño years, the affected areas and the severity of certain agricultural pests expand significantly. Major pests like rice planthoppers and those affecting corn often show faster breeding rates during El Niño years, and a much wider distribution. Farmers not only have to deal with droughts and floods, but they also have to race against pests to save their harvests. This double blow is often devastating. As the world's largest consumer of grain, China's food security status directly affects the quality of life for 1,400,000,000 people. During El Niño years, China's grain production faces multiple pressures. Corn and soybeans in the northeast region may encounter droughts in the summer, impacting their yields. Winter wheat in North China may face freezing damage in the spring. In the Yangtze River Basin, rice production may be damaged by abnormal plum rains. When these localized impacts are combined, They can cause significant fluctuations in national grain production. However, the impact of El Niño on global food security is not evenly distributed. Developing countries that rely heavily on food imports are often the most vulnerable when hit by El Niño. Taking Kenya and Ethiopia in the Horn of Africa as examples, these countries have weak agricultural infrastructure. Farmers lack access to drought-resistant and flood-resistant crop varieties and reliable irrigation systems. Once El Niño causes abnormal rainy seasons, they have almost no room to maneuver. They can only watch helplessly as their crops wither and hunger sets in. The 2011 East African famine caused hundreds of thousands of deaths. Behind this catastrophe was the driving force of El Niño. In this era of globalization, climate change is no longer just an environmental issue. It has become a profound matter of humanitarian concern and fairness. The impact of El Niño reaches from the equatorial Pacific all the way to the dinner tables of the most vulnerable. While humanity frets over the economic fallout of El Niño, other life on Earth is, in a silent way, bearing the consequences of this climate catastrophe. Coral reefs are among the most direct victims, and their story is truly heartbreaking. Coral reefs cover less than 1% of the ocean floor. Yet they support 1/4 of all marine species. They are known as the rainforests of the sea. These vibrant, colorful underwater forests provide food, breeding grounds, and shelter for countless marine creatures. Their existence is essential to the basic functioning of the entire marine ecosystem. However, coral is also one of the most sensitive organisms to changes in water temperature. When sea temperatures rise abnormally, corals make a desperate move. They expel the symbiotic algae living within them. These algae provide the corals with their brilliant colors and most of their nutritional needs. Without them, the coral gradually turns white. This process is known as bleaching. Bleaching does not equal death. If the water temperature can return to normal within a few weeks, the coral still has a chance to recover. But if, after bleaching occurs, the water temperature remains abnormally high, or if the bleaching happens repeatedly, the coral may face death. From 2016 to 2017, an epic coral bleaching event swept across the Great Barrier Reef. The Great Barrier Reef is the largest coral reef system on Earth, stretching over 2,300 kilometers, and composed of thousands of individual reefs. During that bleaching event, more than 29% of the coral died in a single bleaching incident. This was the most devastating bleaching tragedy in the history of the Great Barrier Reef. Follow-up investigations by scientists reveal that, by the year 2018, the coral cover of the Great Barrier Reef had already dropped by about 30% compared to 2016. The once thriving coral reefs have now turned into coral graveyards. What triggered this tragic bleaching event was none other than the Super El Niño of 2015 to 2016. The El Niño caused the southwestern Pacific to experience abnormally high water temperatures, which provided a breeding ground for coral bleaching. While not every El Niño triggers such devastating bleaching, statistical data shows that there is a clear correlation between bleaching events and El Niño. El Niño is becoming one of the most direct threats facing coral reefs, and the survival of these reefs is deeply linked to the future of the global marine ecosystem. It is not just the coral sending out an SOS. The droughts brought on by El Niño are creating an ecological disaster in the heart of the Amazon rainforest. The Amazon rainforest is the lungs of our planet, nurturing 1/10 of all species on Earth. and storing massive amounts of carbon. However, between 2019 and 2020, the Amazon region suffered record-breaking, massive wildfires. Both the number of fires and the area burned shattered all historical records. This burning of the planet's lungs has weakened Earth's ability to regulate atmospheric carbon levels, and the long-term consequences are impossible to fully measure. The wildfire season on the west coast of North America is also becoming increasingly long and intense due to the impact of El Niño. The forests of California and Oregon have turned into highly flammable powder kegs under the dual pressure of extreme heat and drought. The Camp Fire in 2018 and the Oregon wildfires in 2020 were each a devastating catastrophe for the ecosystem. Billions of animals have lost their lives and homes in this silent war, and these disasters are tied to the climate. Anomalies caused by El Niño in an inseparable cause and effect relationship. The polar regions are also struggling to breathe under the shadow of El Niño. The melting rate of sea ice seems to accelerate during El Niño years. The abnormally warm seawater is eroding the very foundation of survival for species like polar bears and seals. In some parts of the Antarctic Peninsula, penguin populations have seen a significant decline. This is closely linked to the disruption of the food chain brought about by El Niño. The Earth's ecosystem is being forced to reshuffle. El Niño is not the only force driving this change. Global warming, habitat destruction, and overfishing all play their own parts. But El Niño, with its unpredictable intensity and frequency, is becoming a major accelerator of the biodiversity crisis. Those silent species have already quietly vanished before humanity even realized it. They don't make the headlines. They don't get discussed on social media. They just, during some El Niño year, due to food shortages or loss of habitat, gradually drift toward extinction. When we talk about the impact of El Niño, we shouldn't just calculate economic losses and human casualties. We should also account for those voiceless victims. The World Bank once released estimates that extreme weather events cause about $390 billion in economic losses globally each year. What lies behind this figure? It is the destruction of infrastructure, the collapse of agricultural production, and the overwhelming burden on public health systems. And the driving force behind these extreme events. El Niño is a power that cannot be ignored. The weight of $390 billion needs more concrete scenarios to be measured. This figure is equivalent to the total annual GDP of some medium-sized countries. Enough to build a clean drinking water system serving hundreds of millions of people, or provide basic education for tens of millions of children. Economic losses are only the surface of the problem. El Niño's economic impact has never been just cold numbers, but rather the turning point in the fates of millions of families. When farmers in Australia go bankrupt due to drought, their family stories will not appear in macroeconomic reports. Yet they constitute this disaster's most authentic human drama. When Peruvian fishermen lose their income because fish have disappeared due to El Niño, their pressure to repay loans, concerns about their children's education and their anxiety over senior care are all social pain points that statistics cannot capture. Economic impacts ultimately come down to people, and human stories are often the heaviest part of any disaster narrative. Agricultural damage is just one facet of El Niño's economic impact. The retail sector will feel the pressure of rising food prices. The insurance industry must face a surge in claims, while construction and manufacturing might fall into a cost crisis due to fluctuations in raw material prices. and the service industry may be the first to take the hit. When consumer spending tightens, these chain reactions form the complete chain of El Niño's economic influence, extending from the ocean to factories, supermarkets, and government offices, and finally reaching the wallet of every ordinary person. A deeper concern lies in the fact that El Niño may be interacting with geopolitical maneuvering to create more complex security crises. Food shortages could lead to social unrest. Refugee waves could threaten the stability of neighboring countries, and disputes over water resources could evolve into regional conflicts. History has proven time and again that climate change is a major catalyst for social instability. El Niño's role in exacerbating this instability is now drawing the attention of international relations researchers and the attention of security policymakers. For developing countries, El Niño is more like an insurmountable divide in development. These nations often have weak economic foundations, and their agricultural technology and early warning systems are far from adequate when facing the impact of El Niño. They have almost no buffer capacity, while developed countries may have more comprehensive response systems. The rising frequency and intensity of extreme weather events are testing their social resilience as well. The outcome of this climate gamble will ultimately determine the direction of global development and equality. Today's El Niño forecasts have reached an accuracy rate of over 80%. This means that in most cases, scientists can quite accurately determine whether an El Niño will occur within the coming months, as well as its general intensity and development trend. This progress did not come easily. It is the culmination of decades of building observation networks, breakthroughs in theoretical research, and advancements in computing technology. However, behind the accuracy figures lies a core problem that remains unsolved. Intensity forecasting. The Super El Niño event of 2015 to 2016 taught the global meteorological community a lesson. In the months leading up to the event, almost all mainstream forecast models predicted that it would be a strong El Niño event. But almost no one predicted that it would be the strongest on record. When the event actually occurred, the magnitude of sea surface temperature anomalies, its duration, and its scope of impact all exceeded the confidence intervals of the model predictions. This predictive failure made the global meteorological community deeply realize that El Niño intensity forecasting remains a massive challenge. Why is intensity forecasting so difficult? The answer lies hidden within the complexity of the ocean-atmosphere coupling system. El Niño is not just simple seawater warming, but a process involving ocean and atmospheric heat and salinity, multiple subsystems like the circulation, an incredibly complex system of interactions. This system has a memory. Past states influence its current path of development. A weak El Niño could evolve into a major event under certain conditions, while a strong El Niño might fizzle out halfway under different circumstances. This non-linear nature makes simple linear extrapolation methods struggle to work. The warming effect of greenhouse gases adds an extra layer of complexity. As the world warms, average sea temperatures in the Pacific are rising. This changes the background conditions for El Niño to occur. Scientists have discovered that against the backdrop of a warming climate, the triggering conditions for El Niño may be shifting, and its intensity distribution might also be changing. Traditional statistical models based on historical data, when faced with a climate system that is constantly shifting, may suffer from systematic bias. What is even more troubling is that the way El Niño makes its entrance each time is never exactly the same. Although scientists distinguish between two basic types, El Niño and La Niña, every single event has its own unique personality. The spatial distribution of sea temperature anomalies differs. Development speeds vary. The duration is different. And the pathways of impact on global climate also vary. This diversity makes it hard for any single model to perfectly capture every possible scenario. To overcome these difficulties, scientists are launching challenges from multiple directions. The Ocean Observation Network is the first frontier. Across the Pacific, the Argo Array, consisting of hundreds of buoys, acts like an ocean weather station network, monitoring the distribution of sea temperature, salinity, and current speed in real time. This data is beamed back to ground stations via satellite, becoming a key input for forecasting models. Satellite remote sensing technology allows scientists to look down from space and see the full picture of global sea surface temperature changes, capturing details that, in traditional observations, might have been missed. Artificial intelligence and machine learning technologies have brought new hope to El Niño forecasting. Compared with traditional physical models, AI models can, from massive amounts of historical data, automatically learn those nonlinear relationships that are hard to describe using physical equations. Some research teams have already developed deep learning-based El Niño forecasting models, which in some aspects show performance superior to traditional models. Of course, AI models have their limitations too. They often lack physical interpretability and may underperform when faced with extremely rare events. This scientific race against uncertainty, its significance goes far beyond academia itself. Every improvement in forecasting accuracy means that governments, businesses, and the public can secure more time to prepare. Every time we gain a deeper understanding of the El Niño mechanism, it may provide new ideas for addressing climate change. This is a marathon with no finish line. But the participants are pushing forward with steady, determined steps. Before the industrial age, El Niño visited roughly every 4 to 5 years. This frequency was maintained for thousands of years, giving humanity the chance to gradually learn its patterns and adapt to its rhythm. However, with the acceleration of global warming, El Niño's behavior patterns are undergoing subtle and profound changes. It seems to have become more frequent, more intense, and even harder to predict. The observational data from scientists has revealed the trajectory of these changes. Over the past few decades, the frequency of El Niño events has been on the rise, but even more concerning is the shifting trend in their intensity. Against the backdrop of global warming, the peak sea surface temperature anomalies in the equatorial Pacific during an El Niño event are gradually climbing higher. This means that events once classified as strong El Niños may, under future climate conditions, only be considered moderate in intensity. And those once-in-a-century super events are likely seeing their probability of occurrence rising significantly. Why is this change happening? The answer lies in how global warming is altering the background temperatures of the Pacific. Before global warming took hold, the average sea surface temperature of the Pacific had a relatively stable baseline. An El Niño event was simply a positive anomaly layered on top of that baseline. But when that baseline itself rises due to greenhouse gas warming, the conditions to trigger an El Niño become easier to meet, and there is more room for it to intensify. Think of it like a glass of water. Once it is already more than half full, adding just a little more makes it much easier to spill over. When the Earth's climate system is already in a warmer state, El Niño is triggered more easily and is more likely to escalate to extreme intensity. The combined effect of the two is currently pushing past the safe boundaries of Earth's climate. These safe boundaries, a concept in climate science, refer to the thresholds within which the Earth's climate system can maintain a relatively stable state. Once these boundaries are crossed, the climate system may enter a new, more unstable status quo. Extreme weather events will become even more frequent and intense. El Niño, as a critical climate oscillation within the Earth's climate system, its interaction with global warming is pushing the system toward these tipping points. If global warming continues, what will become of El Niño? This is a cutting-edge question scientists are working hard to answer. Predictions based on climate models indicate that, over the remainder of this century, the frequency of El Niño may rise even further. Its intensity may continue to strengthen, and its spatial distribution and temporal evolution patterns may also undergo significant changes. Those climate events that seem unprecedented today might, within a certain window in the future, turn from breaking news into the new normal. This is not alarmist rhetoric. It is a scientific projection, extrapolated from current trends. Even more concerning is that, between El Niño and global warming, there may exist a positive feedback loop. The rising sea surface temperatures in the tropical Pacific caused by El Niño will further drive global warming, while global warming, in turn, will provide more favorable conditions for the next El Niño to occur. These two processes reinforce each other, creating a cycle that is difficult to break. To break this cycle, we need large-scale greenhouse gas emission reduction actions worldwide. And that is precisely one of the greatest challenges currently facing the international community. Located in the East Asian monsoon region, China faces particularly complex impacts from El Niño. This influence is not unidirectional. It is multidimensional. It is not just a simple matter of rain or shine, but a chain reaction transmitted through the atmospheric circulation network. Understanding how El Niño manifests in China is the prerequisite for developing effective response strategies. A warm winter is one of the effects of El Niño, most frequently mentioned by the Chinese public. During an El Niño year, the cold air activity affecting China in winter tends to be weaker, causing temperatures across most of the country to be higher than average. In some ways, this kind of warm winter is actually welcome. Heating costs in northern regions go down, and road traffic becomes safer. But a warm winter doesn't just bring good news. Research shows that there is a link between warm winters and the high incidence of respiratory diseases like the flu. When a winter that should be cold turns mild, certain pathogens may find it easier to survive and spread. Floods in the south and droughts in the north are another significant characteristic of El Niño's impact on China. During an El Niño year, the position and strength of the western Pacific subtropical high often become abnormal, which shifts the transport paths of monsoon moisture. South China might see more rainfall than usual, while North and Northeast China could face even more severe drought. This abnormal precipitation pattern, for a country like China, where water resources are already unevenly distributed, presents an extra challenge. Extreme summer heat is another hidden concern brought by El Niño. Under the combined influence of global warming and El Niño, records for the highest summer temperatures in parts of China are being broken time and again. In the summer of 2023, North China experienced rare and extreme heat. Multiple weather stations recorded all-time high temperatures. This kind of heat not only threatens human health, but also poses a severe test for agriculture, power supply, and urban operations. Although we cannot simply attribute every instance of extreme heat solely to El Niño, the probability of such extreme events occurring is indeed much higher during El Niño years. Historical data provides solid support for these theoretical mechanisms. The massive floods of 1998 are still fresh in the memories of countless people. That year, major floods hit the Yangtze, Nenjiang, and Songhua rivers simultaneously. The number of people affected reached into the hundreds of millions. Direct economic losses totaled hundreds of billions. Historical climate analysis reveals that, between 1997 and 1998, the atmospheric circulation anomalies caused by a powerful El Niño were among the key drivers of those floods. During the El Niño years of 2015 to 2016, China experienced a noticeably abnormal, warm winter. Many cities broke their all-time records for winter temperatures. Behind the extreme heavy rains in the north in 2023, we can trace the same cause: the disruption of atmospheric circulation by El Niño. Behind every news headline about extreme climate events, El Niño is almost always lurking in the background. Looking at this from a broader perspective, El Niño is reshaping China's water security landscape, agricultural planning, and urban resilience. Regarding water resource security, the shifts in precipitation patterns caused by El Niño have intensified the imbalance in China's water distribution across time and space. The northern regions were already facing severe water shortages, and the droughts triggered by El Niño only threatened to make a bad situation worse. While the southern regions are generally humid, the risk of flooding caused by El Niño is something that cannot be ignored. In terms of agricultural planning, the impact of El Niño on major grain-producing regions is redrawing the risk map for China's agricultural production. How we ensure food security against a backdrop of increasing climate uncertainty is a strategic issue that requires systemic thinking. Regarding urban resilience, the rising frequency of extreme weather events places much higher demands on urban infrastructure, emergency management, and public services. Can our drainage systems handle even heavier downpours? Can our power grids withstand longer spells of extreme heat? Is our healthcare system truly prepared to deal with more frequent cases of heat stroke? These are the questions waiting for answers. For the average person, understanding El Niño isn't about becoming a climate expert, but rather to better understand the world we live in and the changes taking place within it. El Niño is not just news from far away, but an invisible force that is affecting our daily lives right now. Understanding it helps us approach things with a more rational and calm attitude. When facing those seemingly baffling reports of extreme weather, when it comes to El Niño, what can an individual actually do? This is a question often asked, and it is one that needs to be taken seriously. Effective personal action isn't about shouting empty slogans, but rather starting from practical and actionable steps, and making a contribution within our own capabilities. When it comes to climate risk awareness, raising consciousness is the most fundamental action. Understanding the basic principles and potential impacts of El Niño, and knowing what kind of risks your own region might face during an El Niño year, is the prerequisite for an effective response. Paying attention to weather forecasts and climate warnings is not about creating anxiety, but about gaining time to prepare. When you know that, next summer, you might face a higher risk of flooding, you can check your home's drainage system in advance, prepare emergency supplies, and learn about evacuation routes. These seemingly minor preparations can save lives at critical moments. In our daily lives, making low-carbon choices is the most direct way to participate in fighting global warming. Reducing fossil fuel consumption, using public transportation, cutting back on single-use plastics, and choosing local, seasonal ingredients. These choices won't directly stop El Niño, but they will help slow down the overall trend of global warming. By contributing our own part between global warming and El Niño, there is a complex interaction at play. While the impact of an individual's actions on the global climate may be minimal. When hundreds of millions of people make the same choices, the cumulative effect cannot be ignored. At a societal level, driving change requires efforts that go beyond individual choices. Engaging in community resilience building, supporting the construction of climate-adaptive infrastructure, and speaking up for vulnerable groups. These actions, while not directly targeting El Niño, can strengthen society as a whole in its ability to cope with the shocks of extreme weather. A resilient community is better equipped to protect its most vulnerable members when El Niño comes knocking at the door. When facing El Niño, what can society do? This is a question that requires systematic thinking, as well as collaboration across multiple sectors. Building early warning systems is the most fundamental line of defense. Today, our capabilities for predicting El Niño are quite mature. Yet in developing countries and underdeveloped regions, there remains a significant gap in the communication and reception of early warning information. Closing this gap so that every community potentially affected by El Niño can receive timely warnings is an urgent priority. Regarding the agricultural sector, agricultural systems in developing countries need to become more resilient against the shocks of El Niño. This includes developing drought and flood-resistant crop varieties, building small-scale irrigation facilities, and expanding agricultural insurance. In terms of improving urban resilience, city drainage systems need to adapt to more extreme rainfall events. Power grids must be able to handle more frequent bouts of extreme heat. And urban green spaces and water bodies need to play a greater role as climate buffers. As for climate financial support, developed nations have a responsibility to support developing countries in coping with climate risks, including the risks associated with El Niño. This isn't just a moral obligation. It's a geopolitical necessity to maintain global stability. El Niño isn't just news from some far-off place. It's a reality unfolding right here, right now. At this very moment, the waters of the equatorial Pacific may be warming, and the Earth's atmospheric circulation may be shifting. The rainfall in some corner of the world might be intensifying or fading away as we speak. Every cycle of El Niño serves as a reminder of a simple yet profound truth. The Earth is an inseparable, unified whole. We share a connection with every single corner of this planet. The choices we make today will define the kind of climate the next generation inherits. This is no empty slogan. It is a serious assessment of future scenarios, grounded in climate science. If we continue to emit greenhouse gases at our current rate, then for the remainder of this century, El Niño events may become more frequent, more intense, and far more unpredictable. The extreme events we witness today could become the new normal in the future. This is not the legacy we should leave for our children and grandchildren. Let us stop being mere bystanders and become active participants in climate action. Such participation doesn't require earth-shattering feats. Nor does it mean fundamentally abandoning the life you lead. It can be found in every small decision to choose public transportation. It can be found in every bit of knowledge we gain about climate risks. It can be found in every instance of speaking up for vulnerable communities. When these actions come together, they form the force that drives social change. It's late now, as you listen to this episode tucked away in your warm bed. On the other side of the world, in the equatorial Pacific, the ocean currents are slowly drifting. Sometimes they warm, and sometimes they cool. This is the rhythm of the Earth's climate system, evolved over billions of years. We cannot stop El Niño from happening, but we are working hard to understand it, predict it, and adapt to it. I hope that the knowledge shared tonight will allow you, before you drift off to sleep, to have a little more understanding of this planet we all call home, and a greater sense of responsibility to protect it. Good night, and may you find yourself in the warm embrace of this planet. As you drift peacefully into sleep,